Imagine a world where cracks in your phone screen vanish overnight. Picture bridges that mend themselves after an earthquake. This is not science fiction, but a glimpse into a future shaped by self-healing and smart materials. These revolutionary materials are poised to transform construction, manufacturing, and our daily lives. They promise a world where products last longer, resources are used more efficiently, and maintenance becomes a task of the past. This incredible potential arises from these materials' ability to mimic nature's remarkable capacity for self-repair. Just as our bodies heal from cuts and bruises, these materials can repair damage, adapt to changing conditions, and even learn from their experiences. This paradigm shift in material science is already driving innovation across industries, from self-healing paints and coatings to self-repairing concrete and asphalt. Self-healing materials are designed to repair damage autonomously, often without any external intervention. They work by incorporating a healing agent, either encapsulated or embedded within the material's matrix. When damage occurs, this healing agent is released and activated, triggering a repair process that mends the damage at the microscopic level. One example is self-healing polymers, widely explored for their potential in various applications. These polymers contain microcapsules filled with a healing agent. When a crack forms, it ruptures the microcapsules, releasing the healing agent, which then polymerizes and seals the crack. This technology is already being used in protective coatings for smartphones and cars, making them more resistant to scratches and minor damage. Smart materials take innovation a step further by not just repairing damage, but also adapting and responding to environmental stimuli. These materials can change their properties in response to changes in temperature, light, pressure, or even magnetic fields. This adaptability makes them ideal for applications requiring dynamic responses and precise control. Shape memory alloys are a prime example of smart materials. These metals can remember their original shape and return to it when exposed to heat. This unique property makes them suitable for various applications, including actuators in aircraft wings that change shape to optimize flight, and self-adjusting braces in orthodontics. Section 4. Building the Future, Applications in Construction and Beyond. The construction industry stands to benefit immensely from self-healing and smart materials. Imagine roads that repair their own potholes or buildings that adjust their insulation properties based on the weather. These possibilities are rapidly moving from the realm of imagination to reality. Self-healing concrete, for example, is already being used in pilot projects around the world. This remarkable material incorporates bacteria that activate upon contact with water, producing limestone that fills cracks and strengthens the concrete. This technology not only extends the lifespan of concrete structures, but also reduces maintenance costs and environmental impact. Section 5. Towards smarter, greener cities, the potential impact. The widespread adoption of self-healing and smart materials has the potential to revolutionize urban development and usher in an era of smarter, more sustainable cities. Buildings could become more energy efficient, infrastructure more resilient, and cities more responsive to the needs of their inhabitants. However, alongside the excitement, it's crucial to acknowledge the challenges. The cost of these materials, scalability of production, and long-term environmental impact are crucial factors that need to be addressed before these materials become mainstream. The question remains, how quickly can we overcome these hurdles and unlock the full potential of these transformative materials? The path to a self-healing future is paved with both exciting opportunities and complex challenges. As we continue to explore and innovate, we might just build a world where everyday objects are not just smart but also incredibly resilient. What role do you envision these materials playing in shaping the future?